Hey, so the next type of rock that we're going to be discussing is igneous rock. Igneous rock forms from magma that cools down into rock. So magma is just liquid rock, and eventually it turns into rock, right, if it cools down. Igneous, think of the root word ignite, to light on fire. So here's igneous rock. Now you notice in this particular image that it says igneous rocks forms from both magma and lava. So the magma is underneath the surface. In this particular case over here, it cools down underneath the surface into granite. Over here, the lava cools down into these types of rocks. So there's two different types of rocks. Basically, it forms on the surface or underneath the surface. We'll get into both of them soon. You can see over here the magma. Generally what happens is the outside of a pool of lava will cool down first, while the inside remains really hot. But it'll eventually all cool down, kind of like the Earth itself, right? If the crust of the Earth cooled down, but the inside is still molten liquid rock. Okay, so the first type of igneous rock we're going to get into is called intrusive igneous. So this is going to be like a major category of rock, just in the same way that there was chemical sedimentary and classic sedimentary and organic sedimentary. So over here we have intrusive igneous, this rock formed when magma cools down below the Earth's surface. Because it's happening inside the Earth, it cools down really slowly. If it was exposed to the colder air on the outside, it will cool down quickly. But instead, that's not what happens. So it takes a long time for it to cool down. And during that time, it has time for large crystals to form. And therefore, it's also coarse grained. It's going to have larger chunks inside of it. And a major example would be granite. So here's our example of granite right there. Granite is incredibly common. A lot of people like to use it for construction purposes. You might have granite countertops in your home or other parts of maybe in bathroom or other things. Not only is it really, really sturdy, but has like an interesting pattern that a lot of people like. So it's often used in that way. The next type we're going to talk about is extrusive igneous. So extrusive. Think intrusive is like the interior, the inside. Extrusive is like the exterior. It's on the outside. Rock formed when magma cools above the Earth's surface. This is actually going to be the most common type of igneous rock that you would stumble upon. Why would that be the case? Well, we live on the surface, right? So we're most likely going to find these types of rocks on the surface of the Earth, even though probably overall inside the Earth there's a lot more types of rock like granite. If you recall back earlier to our unit learning about continental crust, a big chunk of the continental crust is made out of granite. But extrusive rock cools really quickly, and that means there's basically no time for crystals to form. So it's often very fine-grained, and some examples over here would be like obsidian, right? So we have this kind of like glassy, sharp shape to it. It was used as arrowheads and spearheads in the past. We have basalt. So here's a thing called basalt. Basalt should be another one that sounds similar. I mentioned before how a big chunk of the continental crust is made out of granite, but almost all of the oceanic crust is made out of basalt. And then we have pumice. Pumice is extremely lightweight, and you'll notice that there's all these little tiny microscopic holes inside of it. That's because as it erupted out of a volcano, it had little tiny air pockets trapped inside of it, and the rock cooled down around the air pockets. Once it landed, the air bubbles popped, the air was let out, but the holes remained there. It wasn't ever filled back in. You can see over here that in the basalt, right, we have a volcano that is erupting, and then very slowly the lava trickles down and it's exposed to the freezing cold waters at the bottom of the ocean where it cools down into basalt. Now, this image over here might look familiar to you. We'll actually get to that in a minute. But that is a type of basalt. Here's another type of igneous rock that I think is interesting to learn about, which is these basalt columns. So these basalt columns over here is known as hexagonal columnar basalt. All right, let's break down what that means. So hexagonal just means hexagon shaped over here. Columnar means it forms in columns. And basalt is the type of rock that was formed. So once upon a time, all of this was formed at the bottom of the ocean. But as it cooled down, it kind of contracted in on itself. So like the inner part cooled down first, and then the rest of it cooled inwards, which is what created this structure there. And this is what's left behind. So this is a place called the Giant's Causeway in Northern Ireland over there. There's actually similar ones in Scotland too. You can find some other places. Almost anywhere where there were some ancient volcanoes there, you might be able to spot it. So here's a little phenomenon, a little pop quiz for you. How can we tell that what we're looking at, this type of rock, is igneous? I'll let you think for a second. All right. Well, it has that hexagonal columnar shape to it. So this is more columnar basalt that we see over here. This is on Iceland. And the other thing is that if you recall before, it's another place where there's a black sand beach. So this is sediments that came from igneous rock. You're only going to find the black sand beaches on volcanic islands. So this is active volcanic island of Iceland, pardon me. And another volcanic island, speaking of which, is Easter Island. So Easter Island is located over here. There were hundreds of these different types of statues. So they're all formed out of basalt, and it's still a mystery today as to why they were made, what was their purpose, why were they arranged in this way. We still don't really know. This is a picture I took of one at the British Museum. So Britain, UK is kind of known for taking things from other countries that they once were involved with and putting it into their own museum. So this is just one of those things. Now, one of the cool things you can find, this is a picture I took when I was in Hawaii, is of a lava tube. So how does a lava tube form? Once upon a time, the lava was flowing. And as it was flowing, the top part of it started to cool down first. I already mentioned that before, how the outer part will cool down first. So as it continues to flow, the entire part gets covered, right? This entire part cooled down before this part did. But as this was happening, this carved into some of the bottom rock over here, making it more rounder. And then eventually, while this stayed the same, this part emptied out. Like, so this was a faster moving lava underneath, and then the lava tube emptied, and now you can walk through it. By the way, this would be entirely in darkness. The only reason it looks like this color is because they have colored lamps inside of it. Just kind of give it a nice moody atmosphere, but it would just look like a hole without it. So if we look at this image, we can see different types of igneous rock. We can see the extrusive rocks, right? And there's two different major types. You have the pyroclastic material. It's stuff that shoots out of the volcano in the air, and that's where you're going to get your volcanic ash and the pumice, super lightweight materials. You're going to have extrusive rocks that form on the surface of it, but that will cool down pretty quickly. That will be like your basalt. Then you have your intrusive rocks that form deep down inside the earth. That'll be like your granite. All right, here's a question for you. So here's what we know. D is an intrusion. This means that all of this was a certain type of rock over here. We know A is a certain type of rock. It's all the same type. B is all the same type. C is all the same type. And D is all the same type. D is an intrusion. So this was once a certain type of rock, but then magma made its way into this area and it melted all of this rock. And then it was hardened. So what I want you to do right now is pause this, and I want you to try to list all of the rock layers in order from youngest to oldest. Okay, so pause if you need to. I want you to have a good think about it. Keep in mind that although there is a line right there separating the two of them, this line, by the way, is a fault, most likely happened due to an earthquake that took place. But everything that's A is the same type of rock. Everything that's B is the same type of rock. Okay, so to make sense of it, we need to put everything back to the way that it originally was. This is how everything originally looked, right? Everything's lined up in this case over here. Other than, so you can imagine that this part, extended outwards and this part was up there, but whatever. So we have everything here. So therefore, we know that at the bottom, if we're actually going to list it as the oldest, right? So the oldest is going to be at the very bottom here because we know about the principle of superposition. So there you go. Now, right above that, the next thing that formed on top of that, after layer C was laid down, layer B was laid down on top of that. We don't know what types of rocks these are. We can assume that it's sedimentary, but we don't know for sure. And then over here, we have, again, this layer was laid out on top of that. Finally, after all that happened, we have some magma that came in, an intrusion of magma that separated this and turned this type of rock over here, parts of C and D and A, turned it all into igneous rock that was formed all the way up there. And then finally, what would have happened, and we could put 5 on this one, although it's really not a different type of rock, but if 5 happened, that means that there was an earthquake that took place that shifted this entire thing downward like that. So the whole part slid down relative to the other part over there, and this is where we're kind of left with what we have today.